Okay, this video will cover the part 2 questions, so 25 through 31 from the June 2019 Geometry Regents. 25, triangle A prime, B prime, C prime is the image of triangle ABC after a dilation with scale factor 1/2 and centered at point A. Is triangle ABC congruent to A prime, B prime, C prime? And explain. So the answer to this is definitely going to be no. And we'll just say no, the triangles are not congruent. And we have to explain that. So the key is that this has been a dilation with a scale factor of 1/2. That's basically going to take each side length of the pre-image and halve it. So there's no way for these two triangles to be congruent and be the same size when you are taking the side lengths and halving them. Okay? So we just have to explain that. And we're going to say that the dilation with a scale factor of 1/2. It's always good to kind of like restate the wording from the questions. Would reduce the size of the triangle making them not congruent. Just so we know, if this question asked about a translation, a reflection, or a rotation, those are all rigid motions, and the answer to that would have been yes. 26, determine and state the area of triangle PQR, and here are the vertices. It says the graph is optional, but I am 100% going to graph. I graph pretty much every time it says it's optional. 3, 5 is Q, and R is 6, 1. Okay, so we're going to use nice straight lines to connect the 3 vertices. I'm going to actually fix that one a little bit. All right, so I don't know if this is a right triangle or not. I'm going to not even pay attention to that. I do every area question the same way. And basically what I use is this method that I call the box it in method. I'm going to create a box or rectangle that surrounds the original shape, because a rectangle is something I can easily find the area of. If you look at that initial initial triangle, PQR, I don't know if it's a right triangle, and I don't have any side lengths that are horizontal or vertical that are easy for me to count. Whereas now, by me doing this method, I've got a rectangle that I can easily find the area of and count the sides because they're horizontal or vertical. And I have these surrounding triangles that I'm shading in here that I can also easily count the sides for, because these have horizontal and vertical sides for the legs. All right, so if we take a look at this, I'm going to call this triangle 1. I'm going to call this one 2, this one 3, just to organize the work. All right, for the rectangle itself, so I'm going to write the area of the rectangle. The base, we're figuring out how many units that is. That's going to be 8. When we're finding the height, it's 10. So 8 times 10, or 80. Now we're going to find the area of triangle 1. That's 1/2 the base times the height. So look at the triangle we labeled 1. I see that this side is 5, and this one is 10. We had already counted that. And that gives me 25. For the area of triangle 2, one side is 3, or one leg is 3. The other leg is 4. So 1/2 of 3 times 4 is 6. And the area of triangle 3, 1/2. The base we can see is 8 here. The height is 6. So 24. So if I want the area of triangle PQR, I could take the area of the box and subtract out those surrounding areas. So 80 minus 25 minus 6 minus 24 gives me 25 units squared for my final area of this triangle. 27, a support wire reaches from the top of a pole to a clamp on the ground. The pole is perpendicular to the level ground and the clamp is 10 feet from the base of the pole. Any of these questions, we saw a ladder one earlier in this exam, a wire. These are all right triangle trig questions. So I'm going to start by drawing a right triangle. The pole is perpendicular to the level ground. So this is the ground. This is the pole. And the clamp is 10 feet from the base of the pole. So here's the clamp, and now I know this distance is 10 feet. The support wire makes a 68-degree angle with the ground. Find the length of the support wire. So this is our wire to the nearest foot, and I'm going to call that X. Using SOHCAHTOA, the opposite side is over where the pole is, the adjacent side is the ground, the hypotenuse is the wire. I have something written on the adjacent side, and I'm looking for the hypotenuse side. So A and H gives me cosine. So cosine of 68 is 10 over X. I'm going to cross multiply here. X cosine 68 is equal to 10. And divide out the cosine 68, and then we go to our calculator for that. Remember, these questions all have partial credit, so definitely show your work for this. We're looking for the nearest foot, so round this to the nearest whole number, and we get 27 feet. 28, in the diagram below, circle O has a radius of 10. If arc AB is 72 degrees, find the area of shaded sector AOB in terms of pi. The formula for area of a sector is, I'm going to abbreviate CA, the central angle, over 360 pi r squared. Well, the central angle is equal to the arc it intercepts, so I'm going to fill in that 72. Pi, radius is 10. We're going to do this in terms of pi. That means I'm not going to put pi in my calculator. I'm just going to put the other stuff. So 72 over 360 times 10 squared. And I get 20, put pi in our answer, and so our answer is 20 pi. 29, on the set of axes below, triangle ABC is congruent to triangle STU. We're going to describe a sequence of rigid motions that maps triangle ABC onto STU. Just a hint on these questions on the Regents, sometimes when we read the word sequence and motions, we think it must be more than one, and it certainly could be, but this means one or more rigid motions has occurred. Okay? So just kind of keep that in mind. And the other thing to keep in mind on these questions is that there's often multiple correct answers. That applies to any question that's short answer, like this one is, meaning not multiple choice, and it's looking for the sequence of rigid motions that maps one onto the other. Okay, so again, multiple correct answers could be correct here or exist. All right, what I like to do is I like to just compare the coordinates. So I have A, B, C of the first triangle, and then I have S, T, U of the other. I'm a person who is good at memorizing those shortcut rules for transformation, so that helps me. So that's why I'm looking at the coordinates. If you're more of a visual person, I'll talk about that too in a second. So if I look at A, that has the coordinates, let's see, -2, 1, 2, 3, 4, 5, -2, 5. B has coordinates -4, 2. And C looks like it has coordinates -4, 6. All right, let's look at the coordinates of STU. So S appears to be -5, -2. T is -2, -4. And U looks like it's -6, -4. So let's compare what's happening. We can see that basically whatever the Y value is, so like look at A, 5, it was negated and it switched spots. It became the X coordinate. So I'm looking for what rule basically takes the Y value, negates it, and then switches the coordinates. That rule is a rotation of 90 degrees counterclockwise. And we always want to state our center of rotation about the origin. And that's going to be my answer to this question. Again, there are multiple correct answers. If you're not good at looking at the coordinates, here's what I would do. I would look at the picture and I could see that it kind of turned on its side. So that's indicating rotation, and it moved one quadrant over this way. Moving one quadrant over means a 90-degree turn. Look at how I drew my arrow. That's not the way the numbers on a clock go. So that's counterclockwise. And that's our answer to this question. The other thing you could do is go the other way. If I started and I went around this way, I moved 3 quadrants over, but that is the way the numbers on a clock go. So that's 270 clockwise, and that's an example of another correct answer to this question. 30 in right triangle PRT, P is 90, altitude is drawn, RT is 17, PR is 15. We want the length of RQ. These are questions on which I use the shortcuts HILS or SAS. If you watch any of my other Regents videos, you'll see me kind of explain that. But just as a quick overview here, looking at the big triangle, that's the hypotenuse. These are the legs. This is the altitude. And these are the 2 segments that make up the hypotenuse. So this problem to me is a HILS problem. HILS is H over L, L over S. The other option, by the way, would be SAS, segment over altitude, altitude over segment. But here's how I know it's a HILS problem, because I know the length of the hypotenuse. I know the length of the leg that it's next to, okay, or that we're working with here. And I am looking for the length of that segment. Once I have that, I can cross multiply and solve. So 225 divided by 17. We're looking to the nearest tenth, so the length of RQ is 13.2. Okay, for number 31, we are given circle O with radius OA. We're asked to use a compass and straight edge to construct an equilateral triangle that's inscribed in circle O. This construction is very similar to when you're asked to construct an inscribed regular hexagon. Very similar. So the key that we're going to do here, I'm just going to turn my paper a little bit, is we need to measure how big the radius is. So I like to bold any point that I'm going to use here. So O is already bolded. I just bolded A. I'm going to put the gold ring of my compass, and if you're using a regular compass, that's fine. I'm going to put the gold ring of my safety compass on O, and I'm going to try and find the letter on my compass that lines up best with A. So keep in mind the holes up here and the holes down here are slightly different. So if something on the top doesn't work, try the bottom. So for me, this one at P looks the best. And I'm just going to kind of keep that in mind. So I'm going to put P off to the side here. Okay. All right. Now that I have that measured, I'm going to turn my compass on my paper the regular way. I'm going to put the gold ring of my compass on A now, and I'm going to use the letter that I just previously found, so P. Make an arc, bold the point. We're going to now just repeat this, going around the circle, compass on the point, arc with P, bold the point. Okay, you can turn your paper and turn your compass however it's comfortable to you. On the gold ring on the point, arc through P, bold the point. We're going to repeat again. And one last time here. Okay, so we should end up, and this construction, just so you know, will always come out slightly imperfect. But that's okay. So basically what we are going to have here is 6 points on our circle. We have our original point, A, and then we added 1, 2, 3, 4, 5 more points, so a total of 6. If we were going to construct a regular hexagon, we would just connect the 6 points. Okay? But this one says an equilateral triangle, so that's using 3 points. So I'm going to pick A. I'm going to pick this one over here, basically every other, and this one here. And I'm just going to use my compass as a straight edge. And I'm going to connect those points. Okay, so I'm picking 3 every other alternating points. once I connect this, my equilateral triangle will be complete. Okay, so here we go. Here's our equilateral triangle that is inscribed in circle O.